is the heuristic search? First, you need to understand the heuristic search. Then we will discuss about all these three algorithms, which is the best first search, heuristic, and the hill climbing. We have just discussed the few hill climbing method in the last lecture. Now, in a detail, we need to discuss all informed search techniques or the heuristic search techniques. So, what is the heuristic search technique? One of the core method AI system used to navigate the problem solving is through the heuristic search technique. What is the heuristic search technique? These techniques are essential for the tasks that involve finding the best path from a starting point to a goal state. And where we are, and where there is a need of finding a best path, then we know that the problem is that big that the infinite time of traversal will be there, such as in a navigation systems or a gameplay and the optimization problem. In these kind of a problems, we need to find the best path here from starting point to a goal state. So here we will discuss about all the how the heuristic search technique works. Now, understanding the heuristic search technique. Heuristic search or the heuristics operates on the search space of a problem, and we have discussed the space search problem also. Heuristic operates on the search space of a problem to find the best or the closest to the optimal solution, right? With the use of a systematic algorithms, various systematic algorithms we will discuss here. In contrast to brute force approach, which checks all possible solutions exhaustively, a heuristic search method uses the heuristic information, as we have discussed just now about calculating the heuristic value. A heuristic search method uses the heuristic information to define a route that seems more plausible than the rest. And the heuristic in this case refer to a set of criteria or the rules of thumb that offer an estimate of a firm's profitability. अब यहाँ पर क्या मतलब है? Simply the best solution. Utilizing the heuristic guiding, the algorithm determines the balance between the exploration and the exploitation, and thus they can successfully tackle the demanding issues. Therefore, they enable an efficient solution finding a process जो कम से कम टाइम में आपको बेस्ट सॉल्यूशन फाइंड करके देगा. So here the balance between the exploration and the exploitation will be there. And what is the significance of a heuristic search in an AI? Why we are using the primary benefit of using a heuristic search technique in AI is their ability to handle the large search spaces when there is a number of possibilities. So in that case, it is useful finding the large search spaces, and heuristic help to prioritize which paths are most likely to lead to a solution. As we have discussed in the state space search also, we have discussed that comes under the space state search. हमने जब problem solve करी थी, we have discussed that which path is need to be followed for getting a solution. So heuristic has to prioritize which paths are most likely to lead to a solution, significantly reducing the number of paths that must be explored, right? This is only speeds up the search process, but also make it feasible to solve the problems that are otherwise too complex to handle with the exact algorithm. So it will speed up the solution. It will give you the best solution in a minimum time here. So what comes under the heuristic search? We have discussed about the state space search. So heuristic search के components क्या हैं? So what comes under the heuristic search? What components? So heuristic search algorithm typically comprise several components. First is your state space. What is a state space? This implies that the totality of all possible states or the settings which is considered to be the solution for a given problem, right? As we have discussed in the state space search, there are three possibility actions that can be performed according to a blank tile. So in that case, we are searching for a space where we can move a tile. So this implies that the totality of all possible states or a setting. What actions can be performed next? All possible states of a particular problem or the initial state, which is considered to be the solution for the given problem. Next component in any problem, in every problem, definitely is the initial state. We need to know the initial state. So the instance in the search tree of the highest level with no null values serving as the initial state of the problem at the hand, right? What is the problem state? Definitely. Then the goal test is the another component. What is the goal test? The exploration phase ensure whether the present state is a terminal or consenting the state in which the problem is solved. So by performing the state space search in every level, you search for the goal, whether the goal has been achieved or not, whether the present state is a goal state or not. So goal test is simply checking a present state, whether it is a goal state or not, or what can be the next state that will be lead us to the goal state. So the exploration phase, we explore our problem, we explore our algorithm or the search technique and ensure that whether we have reached to the goal state or not. Then the successor function. So this creates a situation where the individual states supplant the current state, which represent the possible moves or the solutions in the problem space. We have discussed this in a space search also. What can be the another situation a individual state can be lead to, right? करंट स्टेट आगे कौन से पॉसिबल मूव्स के साथ गोल स्टेट तक हमें लेकर जा सकती है, दैट इज द सक्सेसर फंक्शन कि इसके नेक्स्ट क्या होगा. Then the heuristic function, which is the important here. The heuristic function or the function of a heuristic is to estimate the value or the heuristic value or distance from a given state to a target state, जिससे हम best possible solution ले सकें कम से कम time में. It helps us to focus the process on regions or the state that has prospect of achieving the goal, which basically possible, which make us possible to achieve our goal. So now, what are the different heuristic search techniques comes under a AI? So first is the types of a heuristic search techniques. We will discuss about the 3 techniques in detail. So here first is your A asterisk search. पहले सारी search techniques का introduction ले लेते हैं. Over the history of a heuristic search algorithm, there have been a lot of techniques created to improve them further and attain the different problem domains. So first is your A search or asterisk algorithm, or we say that simply A star search algorithm. What is the A star search algorithm? What comes under it? So here is perhaps the most well-known heuristic search algorithm. It uses the best first search and find the least cost path from the given initial node to a target node, right? So it's a best search technique here which find the least cost path, मतलब सबसे कम टाइम लगेगा, सबसे कम वैल्यूज इसमें हम कंसिडर करेंगे इनिशियल स्टेट से टारगेट स्टेट पर जाने के लिए. So it has a heuristic function. Definitely we need to calculate the heuristic function, often denoted as function equal to g plus n, g plus h, and f equals to g plus hn. What is this? Where the g is the cost, g is representing the cost from the start node n, and h is the heuristic that estimates the cost of the cheapest path from the state node n to the goal node, right? So here g represent the cost and h represent the heuristic function. And A asterisk is widely used in path finding and the graph traversal. When we are talking about the graph traversal, we will search for the path finding when there is a need of finding a path from one state to another state or from initial state to a goal state, a particular best possible path with a low cost, we will use the A asterisk search algorithm. Another is your greedy best first search. What comes under the greedy best first search? Greedy best first search expands the node that is closest to the goal as estimated by the heuristic function, right? So unlike A asterisk, which takes into account the cost of a path from start node to a current node, right? The greedy first search only prioritizes the estimated cost from the current node to the goal node, right? So here we are talking about completing from a current node to the goal node here. it it makes it faster but less optimal than the A asterisk, right? Optimal best solution will be given by the A asterisk here. So it can be the fast, greedy, best first search कि जल्दी से जल्दी उसको goal state मिल जाए. How? A asterisk क्या करता है? The cost of a path from start node to the current node, it basically work on the cost here. But the best first search works under the estimated, prioritize the estimated cost from the current to the goal state here. मतलब it can be work fast, but the optimal solution will be provided by the A asterisk. We will discuss in detail all these algorithms. Then the hill climbing, another is the hill climbing. Comes under the heuristic approach and we have discussed the hill climbing approach in the last lecture also. Hill climbing क्या है? क्या कोई बता सकता है? We have discussed in the last lecture about the hill climbing. Can any one of you tell me about the hill climbing? Where we use the hill climbing approach? Can any one of you tell me about the hill climbing? Hill climbing approach कौन सी होती है? Hill climbing search technique. We have discussed in the last lecture about this. We have taken the we have discussed about the peak value. We have discussed about the elevation. We have discussed about the, we have seen one diagram which is basically showing the peak of a system. So hill climbing algorithm is basically used as a local search algorithm which basically continuously move in the direction of increasing the elevation, increasing the elevation to find the peak of the mountain or the best solution to the problem. Peak of a mountain or hill climbing, basically name is suggesting the peak of a mountain is the best solution of my problem here. So hill climbing is a search technique which continuously move in the direction of increasing the elevation value. Increasing the elevation value to find the peak of a mountain or the best solution to the problem, and it terminates when it reaches a peak value where no neighbor node has a, or where no neighbor has a higher peak value than its peak value. So what is the hill climbing? Hill climbing is a heuristic search approach used for mathematical optimization problems. It is variant of the gradient ascent method. Starting from a random point, the algorithm takes the steps in the direction of increasing the elevation or the value to find the peak of a mountain or the optimization or the optimal solution to the problem. However, it may settle for a local maximum and not reach the global maximum. Right? What do you mean by the local maximum or the global maximum here? Because it's a local search technique. It's a local search technique and it is also known as a greedy local search, and it only looks to its good immediate neighbor state, not beyond that. It's only search for the neighbor state, whether it should be only best possible above to the neighbor state only. So it basically work for the local maximum. अपनी आसपास की state से it will be maximum but not as a global maximum. और भी कोई best solution हो सकता है, right? So hill climbing is just comparing it with the neighbor only. Now simulated annealing. This is not in our syllabus, but we need to know in terms of our heuristic search techniques, just the definition. What is the simulating annealing? Inspired by the process of annealing in metallurgy, simulating annealing is a probabilistic technique for approximating the global optimal of a given function, and it allows the algorithm to jump out of any local optimums in search of a global optimum. So what is the annealing? कोई बता सकता है? So as we are talking here about the metallurgy, so annealing is just the heating or heat and allow it to cool slowly. We are just discussing about the heating of a process, right? So what comes under the annealing algorithm? As we have discussed, it's just basically search for the global optimum of a given function. Then the beam search technique is also there. Beam search technique or beam search is a heuristic search algorithm that explore a graph by expanding the most prominent nodes in the limited set or a beam, and the beam which limits the number of a node stored in a memory. They are crucial role in performance and the accuracy of a search. Simply, we are talking about a block of a nodes that comes under the local memory here. We are talking about here the beam search, right? So what are the applications where basically we are using the heuristic search? We are discussing heuristic search in the game playing. We are using the heuristic search in the optimization, pathfinding, robotics, and the natural language processing. So heuristic search techniques finds the application in a wide range of problem-solving scenarios. First is a pathfinding. Pathfinding, when we need to discover the shortest distance that can be found from the start point to the destination point at the point of a coordinates or a graph. So pathfinding, when we need to find the shortest distance from a start point to the destination point. Then the optimization, solving the problem of a optimal distribution of a resources, planning or posting to achieve the maximum result. सबसे ज़्यादा issue आता कहाँ पर है? When we talk about a big data, when we talk about the AI is working on a different kinds of a data. So optimization is the best. Optimization need to be followed here. We need the best possible algorithm that can plan our resources, that can help the resource manager in a system to distribute the resources in that manner that can plan the resource distribution, right? So optimization is used when we are solving the problems of optimal distribution of a resources in a particular system, planning and posting to achieve the maximum results so that each and every time the resource is available. Then the game playing is the another application when we are where we are using the heuristic approach. Why? The agency of a AI with the some board games that which is chess or Go isn't giving guidance and making strategy-based decisions to the agency, right? Different nodes where it can be moved to a further for finding the optimal solution again. Now the robotics, scheduling the robots. Another application in the heuristic search technique is the scheduling the robots, location and movement to guide carefully expeditions and perform given tasks with high efficiency. So simply guiding a robot, right? Location and the movement, and then we are using the natural language processing. Language processing tasks involving search algorithm, when there is a need of a search algorithms in a language processing, such as a parsing or semantic analysis could be outlined, right? So here we are talking about various language, natural language processing. So what are the application of a heuristic search techniques? Pathfinding, optimization, game playing, robotics, and the natural language processing. Now, what is an advantage of a heuristic approach? We have discussed. Heuristic approach is efficient, optimal, and the versatility. Now, versatility is the, again, when we talk about in a form of a big data, we are talking about the variety of a data with the different kinds of a format. Or here, when we are talking about a problem, we are talking about various problems comes under the various domains. Number of a problems apply to a various domains, not a domain specific here. So heuristic search techniques offer several advantages when we talk about the efficiency, as they are capable of aggressively digesting the large areas for the more promising lines. They can allot more time and resources to investigate that area. So somewhere the planning is there, somewhere the movement is there, somewhere the finding the best time possible is there. So efficiency will be improved. Then the optimality. If the methods that an algorithm use and advisable, A asterisk guarantees of an optimal result, right? Then the versatility, we have discussed. Heuristic search methods encompasses a spectrum of problems that are applied to various domains of a problem. So here the different or the scattered, if we talk about the applying the approach in a scattered way, we can use the heuristic approach here. Now, what is the limitation? Heuristic quality. When we are talking about the heuristic quality, we are talking about finding the heuristic value here. Space complexity, when there is a possibility of finding the number of space, and when we are talking about the complex search technique, then the domain specificity. So heuristic quality is the power of heuristic search strongly depends on the quality of a function, the heuristic horizon. If the heuristic are constructing thoughtlessly, then their level of performance may be low or inefficient. So what approach we are using, right? From randomly we are using, or we are approaching any mathematical approach here to finding a particular heuristic value. So what approach is going to be used, or the quality of a heuristic value depends completely, the performance of a search technique or the algorithm depends on the heuristic value here. Then the space complexity. The main requirement for some heuristic search algorithm could be the huge memory size in comparison with the others, right? Because every time you need to save that state, especially in the cases where the search space considerably increases, or when the large problem we are talking about here. Then the domain specificity, it is often the case that devising efficient heuristic depends on the specifics of the domain, or a challenge abstract to develop a generic approach. Now, what do you understand by the domain specificity? Here, when we are talking about the different domains, which is the advantage also of a heuristic, and when we are not using a high quality heuristic value, then there is a challenge for us to develop a generic approaches that will be work for the each and every domain here. So domain specificity will be there based on a heuristic value. So let's take a view of a asterisk search algorithm. Before that, we will talk about, before the AST, we will talk about first the hill climbing, then we will talk about the BFS and the AST. So let's talk about first hill climbing, because we had already discussed about the hill climbing in the last lecture. Now complete the hill climbing. First, we will complete our hill climbing topic in an artificial intelligence. So what is a hill climbing in artificial intelligence? As we have discussed, अभी हमने सारी definitions देखी है. We have discussed all the search techniques. We have taken the overview of all the search techniques that comes under the heuristic searches. And one of the search technique is a hill climbing in artificial intelligence. So hill climbing is widely used optimization algorithm in the AI that helps to find the best possible solution to a given problem as a part of a local search algorithm family. Why the local search algorithm family? Because it will consider only the neighboring. So it is often applied to the optimization problem where the goal is to identify the optimal solution from a set of potential candidates. So what comes under the AI? We have discussed. So AI, what comes under the hill climbing? Hill climbing is a heuristic search algorithm that comes under the heuristic search algorithm used primarily for the mathematical optimization problems in the AI. ये हमें समझ में आता है. Then it is form of a local search, which means it focuses on finding the optimal solution by making the incremental changes. First, it will check its state based on its neighboring states. If it is higher, then it will move further. So incremental changes to an existing solution, and then evaluating whether the new solution is better than the current one, right? It will move further in an elevation state. So the process is analogous to climbing a hill where you continuously seek to improve your position until you reach to the top. After that, there is no possibility of improving or the local maximum from where no further improvement can be made. Simply, here we are talking about a particular current state will be moved to its goal state, that is the final state, or that is the local maximum of a particular state. After that, it cannot be moved to reach to a further solution. So hill climbing is a fundamental concept in AI because of its simplicity, efficiency and effectiveness in a certain scenarios, especially when dealing with optimization problems or finding solutions in a large search spaces. We will talk about one state only and we will reach to the local maximum to that particular state only. और अगर first time में, if in a first time only we get the goal state, that is the best possible solution. It comes under the hill climbing. So how does the hill climbing algorithm works? In the hill climbing algorithm, the process begins with the initial solution or the initial state or the problem state, which is then iteratively improved by making small incremental changes. We will perform few changes, incremental changes that will help us to reach to the goal state. And these changes are evaluated by a heuristic function to determine the quality of a solution, right? With the help of a best heuristic function. And the algorithm continue to make these adjustments until it reaches a local maximum. Which is what is a local maximum, after which the further incremental state is not possible. A point where no further improvement can be made with the current set of the moves here. Right? So how does the hill climbing work? From the initial state, one by one, we will move to the top, and if that state will reach to a local maximum, that is basically the best possible moves to reach to a goal state, to that state only. So what is the basic concept behind the hill climbing, or what components comes under the hill climbing, or what are the steps comes under the hill climbing? First is the initial state. We need to know the initial state. Start with any random solution or the initial state or the arbitrary or the random solution. कोई भी एक state लेंगे, then neighboring states. Identifying the neighboring states of a current solution by making small adjustment, mutations or the tweaks here. So here we will perform few changes and identify the neighboring states. Move to the neighbor. If one of the neighboring state offer a better solution, we will move to a neighbor according to some evaluation function and move to this new state, right? Termination, repeat this process until no neighboring state is better than a current state, right? At this point, we have reached, or you have reached to a local maximum or the minimum, depending on whether you are maximizing or the minimizing. So hill climbing in a mathematic optimization, how basically we use the hill climbing. So hill climbing often used for solving the mathematical optimization problem in an AI. So if the question will be asked for which search algorithm in a heuristic search algorithm is used for solving the mathematical optimization problems, you use the hill climbing algorithm. With a good heuristic function and the last sets of an input, right? We know we have a last sets of an input here. Hill climbing can find a sufficiently good solution in a reasonable amount of a time, although it may not always find the global optimization optimal maximum, right? We are just talking about the local maximum, local optimal maximum here. So in the mathematical optimization, hill climbing is commonly applied to the problems that involve maximizing or minimizing a real function. For example, traveling salesman problem, right? The traveling salesman problem objective is to minimize the distance traveled by the salesman while visiting the multiple cities. So here basically it will use the minimizing a real function. So what is the heuristic function and how basically in each and every heuristic search algorithm there is a need of a heuristic function. Please mute yourself. Okay. So what is a heuristic function? Heuristic function is a function that ranks the possible alternative at any branching step in a search algorithm, right? That ranks कि क्या possible best moves है further, right? तो वो rank करेगा based on available information. और what is the available information? Available information about the actions, available information about the moves, available information about the initial state, right? So it basically rank the possible alternative at any branching step in search algorithm based on the available information.
मेकिंग
It
चार्ज
helps the
कितना सब कर
algorithm
लगे था
select. Every one of you, please
कितना
mute
परसेंट
yourself. Let me disable your mics. So heuristic function is a function that ranks the possible alternative at any branching steps in a search algorithm based on available information. It helps the algorithm select the best route among various possible paths. How? Because it ranks the alternatives at every branching of a search algorithm. So definitely it will help to select the best route among various possible paths, thus guiding the search towards a good solution efficiently, right? How? Based on a heuristic function value, based on a heuristic rank. Heuristic function, basically what the heuristic function will do, what is the rank of a present state of a solution, right? Can any one of you tell me about the heuristic function? Yes. Or in simple language, how we will define a heuristic function? Heuristic function is simply a method used in a search algorithm to decide which path to take at each step. आगे कौन सा route लेना है? Which path to take at each step? And what is the each step here? When we are showing any algorithm in form of a graph, in form of a branching, the each step is the branching step, right? So again, I am talking about a heuristic function. Heuristic function वो है जो एक रैंक देता है, एक पॉसिबल रैंक देता है एवरी ब्रांचिंग स्टेप में, जिससे जो भी इंफॉर्मेशन अवेलेबल है बेस्ड ऑन दैट अवेलेबल इंफॉर्मेशन, सो दैट द एल्गोरिथम कैन सेलेक्ट द बेस्ट पॉसिबल रूट, राइट, among various possible paths. So what is the feature of a hill climbing algorithm? If we talk about a hill climbing algorithm, feature is a variant of generating and testing the algorithm. Every time it is testing the algorithm, every time it's generating the different variants of algorithm. How? Hill climbing is a specific variant of a generating and testing algorithm. The process involves generating the possible solution. At every step, it's generating the possible solution or the possible paths. The algorithm creates the potential solutions within a search space or based on a present state. Then testing solution. Each generated solution is evaluated to determine if it meets the desired criteria or not. Or simply we are talking about here testing the goal state, right? Goal test will be done. Then what is the iteration? Another feature we are talking about here the invariant of a generating and testing algorithm. We had talked about generating the possible solution and the testing solution, which is testing the goal test, testing the goal state, and the iteration. If a satisfactory solution is found, the algorithm terminates. Otherwise, it returns to generation the another step. So this iterative feedback mechanism allow hill climbing to refine its search by using the information from the previous evaluation to inform future moves in a search spaces. So simply, or we can say that if the particular solution has been found for a particular problem, we will move to the another possible solution of that problem, right? If we talk about in a healthcare, we had talked about that the AI is the application of AI is in a healthcare also. When we are basically researching on a particular disease also. So if a particular disease has been researched to a particular state, we will increment from that state only. So this comes under the iterative approach. So iterative feedback mechanism allow hill climbing to define its search by using the information from the previous evaluation to inform the future moves in the search spaces. What will be the other future moves to search? for a particular disease, right? Then the greedy approach. What is a greedy approach? What is the greedy approach? Or another feature of a hill climbing, that it's a greedy approach. We say it's a greedy approach. How? The hill climbing algorithm employs a greedy approach, meaning that at each step, it moves in the direction that optimize the objective function. So that optimize the objective function means this strategy aim to find the optimal solution, always the best optimal solution. Hamesha each state or each branching step will talk about its neighbor steps, right? Whether the neighboring state is better or I am the better, and the neighboring state is better, then it will move to the neighboring state. That is a greedy approach. So this strategy aims to find the optimal solution efficiently by making the best immediate choice without considering the overall problem context. Immediately, whether if it finds the neighboring state at the higher level, then it will choose the neighboring state, right? So types of hill climbing. So simple hill climbing, what comes under the simple hill climbing? Simple hill climbing is straightforward variant of a hill climbing where the algorithm evaluates each neighboring node one by one and select the first node that offers an improvement over the current. So simple hill climbing, it simply select the first node that offers an improvement over the current one. So how the algorithm works under the simple hill climbing? It first evaluates the initial state. First step that it will evaluate the initial state. If it is a goal state, return the success, definitely. And in second, make the initial state as the current state, and then the loop will start because we are talking about here the iterations. Loop until a solution is found or no operator can be achieved, or no operators can be applied, or no operations can be applied further. So again, we will select in the loop, what we will do, select a new state that has not yet been applied to a current state, evaluate a new state, and if the new state is a goal, then return the success. If the new state improves upon the current state, or the new state is basically near to a goal state, make it a current state and continue. We will pass our parser to the that improved state, and we will make that improved state as a current state. Then if doesn't improve, continue the searching neighboring states. We will search for a neighboring state, right? Exit the function if no better state is found. Definitely, simply it works as a exit the function if no state has been found. If no better state has been found, because whatever the initial state we are considering, whatever the state we have just selected, that considered as a best possible solution. Another type of a simple hill climbing is steepest ascent hill climbing. Now, steepest ascent hill climbing, as the name is showing, steepest ascent hill climbing is an enhanced version of a simple hill climbing. Instead of moving to the first neighboring node that improves the state, it evaluates all the neighbors and move to the one offering the highest improvement, which is the steepest ascent, जो सबसे high peak पे लेकर जा रहा है the neighboring state. It will not look for the first neighboring state. What the state will do? It will simply look for the first neighboring state, and if it is higher than the current state, it will move to the first neighboring state or the first neighboring node. But the steepest ascent hill climber will evaluate all the neighbors first and then choose that neighbor which is having the highest offering or the highest improvement. So how the steepest ascent hill climbing will work? What are the steps comes under the steepest ascent hill climbing? It evaluates the initial state. Definitely, it will evaluate the initial state. First step will be same. If the goal state is found, it will return the success. Then, in a second step, make the initial state the current state, right? जो भी initial state उसने evaluate कर लिया, तो it not find as a goal state, it will start its looping or the initialization from the current state. Then, in the third step, the looping will be start. Repeat until the solution is found or the current state remains unchanged, right? These three steps are the same as we have discussed. Now, what comes under the repeat until the solution is found or the current state remains unchanged? First step is it will select a new state that hasn't been applied to a current state, right? New state it will select which is not the next state of a current state. So initialize a best state variable and evaluate all the neighboring states. So first in a loop, it will initialize the best state variable and then starting evaluating all the neighboring states. This step is just different from the previous hill climbing algorithm. Then if the better state is found, update the best state, right? Best state को update कर देगा. If the best state is the goal state, return the success. If the best state improve from the current state, make the new state or new current state and repeat. If the goal state has been found with the best state, then it will return the success. But if it's not found, it will convert the best state as a new current state and will repeat again the loop and exit the function if no better state is found. Better state is found from the current state from where the algo has been started or the looping has been started. Another type is the stochastic hill climbing. Now, what is the stochastic hill climbing? It introduces the randomness into a search process. Now, it introduce the randomness. Randomly, we will evaluate and we will take the as a next stage. Instead of evaluating all the neighbors or selecting the first improvement, it selects a random neighboring node and decide whether to move based on its improvement over the current state, right? So it works on a random function simply. What we will do, or we will, if we use any programming language to implement this algorithm, we use a random function or the random module of that programming language, right? So simply this hill climbing approach or the algorithm will work on the randomness. We will choose any random neighbor and we will then decide whether to move to that neighbor or not based on that whether that neighboring state is the improved state of a current state or not, or it is near to a goal state or not. So algorithm here, first step is same. We will evaluate the initial state. What we will evaluate whether the initial state is a goal state. If it is a goal state, we will return the success. First step is same. Then in the next step, make the initial state the current state, right? We will make the initial state as a current state. Then repeat until a solution is found for the current state does not change. Again, this looping step is same. Now, how it work? It work on the successor function. Apply the successor function to the current state, right, and generate all neighboring states. First, in a looping, we will, or in the iteration, we will search for the success. We will apply the successor function, and we will generate all the neighboring states of a current state. Then in the next step, we will choose a random neighboring state based on our probability function. So here we will use first the successor function for generating all the neighboring states. Then we use the probability function to choose any random neighboring states, right? And when the random neighboring state has been chosen, is the chosen state is the better than the current state, we will make it a new current state. Or if the selected neighbor state is the goal state, we will return the success here. Simply, all the steps are same. Only few changes are there. In the first type of a hill climbing, we are talking about that we will simply use a straight method. We will simply choose a first neighboring state as a successor state of our current state, and we will apply further steps to that first neighboring state if that state is the improved state of our current state, right? And in the next steepest in that type of a hill climbing, we are just discussing about, we will evaluate all the neighboring states, and after evaluating all the neighboring states, we will find the best neighboring state or the which has having the highest peak, uh, and for according to that neighboring state, we will decide are the another successor states. And in the last stochastic hill climbing search algorithm, we are talking about the random function, right? We will take the, after generating all the neighboring states, we will just take the or choose the random neighboring state. And then further we will check whether that neighboring state is the improved version of a current state, or whether that neighboring state is a goal state, and then we will return a success according to that. So we have discussed about the state space searches, and now we will discuss about the state space diagram in a hill climbing. In a hill climbing algorithm, the state space diagram is a visual representation of all the possible states that the search algorithm can reach, plotted against the values of objective function, the function we aim to maximize. So in a state space diagram, simply the visualization is there. So we are talking about the graph here. So the x-axis represent the state spaces, which includes all the possible states or the configuration that the algorithm can reach, and the y-axis represent the value of the objective function it reach corresponding to the each state. And the optimal solution in the state space diagram is represented by state where the objective function reaches to its maximum value, also known as a global maximum. So this we have discussed, right? हमने last lecture में भी ये diagram देखा था what is a global maximum, what is a local maximum, what is a shoulder, and what is a flat local maximum, what is representing as a state space, what is representing as an objective function, right? State space is representing, or here the state space has been showing at the x-axis and the objective function is showing at the y-axis. And the key regions in a state space diagram is the local maximum. So what's the local maximum? क्या कोई बता सकता है? Can anyone of you tell me about the local maximum? हमने सब last lecture में discuss किया है. I am allowing the mics now. Because other algorithms we will discuss tomorrow. आज हम hill climbing को, today we will finish our hill climbing. Can any one of you tell me about the local maximum? What is the local maximum? We had discussed all these regions yesterday. Or any one of you having any problem in our today lecture about the, we have discussed about the heuristic search techniques. We have discussed about the various definitions that comes under the heuristic search techniques. We have discussed about the hill climbing heuristic search technique in detail today. Tomorrow we will discuss about the advantage and the disadvantages also. And then we will discuss about the asterisk and the really best first search also in the heuristic search techniques.